Hi everybody, on Indiegogo.com. I'm the first and original inventor of these contrivances you see here on my CAD software. Yeah, I have to apologize right now. I'm a little tipsy, so I may not be able to remember everything right off the top of my head. These are my tricycle and bicycle designs for my super fast contrivances here. The upper one is the bicycle, as you can see here. I will try to zoom in as best I can. That's about as close as I can get. My computer's a little sticky. Here we go. Okay, here it is. It has a dynamo, an alternator, DC AC alternator right here. Has a chain drive, which I didn't put in because I don't have the electrical system designed on it. There's the alternator. It has a belt drive from this here wheel. This wheel goes to this wheel here and drives this alternator and creates 12 volt DC, 12 volts. I don't know how many AC volts it would create, but there's an electrical panel up here on the handlebars right here where I will put the instruments. I have it all aligned with the chain drive right down to the thousandths of an inch. So the chain drive is pretty much figured out. There's no errors. It's hydraulically powered. There's 100 pounds of force at full speed on this bicycle. It has, I intend to call this bicycle MACH 0.3 because it should be capable of achieving that speed at 100 pounds of force on the pedals. On the tricycle down here, the rear end has a differential built inside of it. I'll show you that here. There's the differential. As you can see, it has spider gears in there. I haven't separated them out in individual drawings yet. This differential fits inside this power transmission. The suspension on this bicycle has a sway bar right there, and although the sway bar is not centered, as you can see on this axle, it does have a bolt that goes through right here, and this piece here will swing when the suspension bounces, so there's no problem with the sway bar. When it moves, it'll swing even though it will control the amount of sway, and the cornering is kept under control by this triangular assembly of the swing arm to the rear wheels. The frame, it's not designed to be abused to go on rough terrain and all that. I'll have to try it out. This is a prototype, so this piece right here may take some considerable force as the weight is applied in cornering and going over bumps. This piece has, however, some support here and here from the loads generated through weight applied through here into here and then into here and through here, but it'll be distributed out through this piece and into the centerpiece of the frame. So it'll also be sent through this piece here as a weight. So I think it'll stand up to some cornering forces fairly well. The suspension has a pretty good spring on it, and there's some clearance in here. Well, where'd it go? There it is. Okay, let's try that again. Has some pretty good clearance there, and loads should turn the shock absorber upwards during bouncing, unless you leave the ground, and then it might bang into this piece here. But besides that, all these pieces up here, all of this, the power plant anyway, will fit down onto this frame of the Tricycle. And let me do a top view for you. As you can see, the wheels of the Tricycle are wider than all the power plant. So when all these pieces are set down onto the Tricycle, there should be plenty of stability. This bicycle should be capable of Mach 0.3, like I said. And by my experience, the bicycle would be a little unstable to control. Since I just went out on a short bicycle ride, I was going to take about 50 miles or 60 miles, and it didn't work out. I put in these stabilizer bars here and here on both sides because there's a lot of wiggle. Let me do a front view. There was a lot of wiggle, and that's what I figured there would be with this bicycle. There would be a lot of wiggle, so I put in these stabilizer bars here and here, front and back. And I also made this piece here, this piece, solid steel. I figure this will be chromoly steel, the main frame, and I made this solid, not hollow, in order to sustain rigidity. It has a piece here, this piece, you can see me lighting it up here. This has bearings, and it's been a while since I put that piece in. It just sort of keeps the pressure from the cranking on the chain rings here from pulling on these axles. When I apply pressure on the crank, it goes through the chain and applies to this chain ring over here, and it would pull on these axles, and this piece here keeps the axles from flexing. So since it's hydraulic, these units here, here and on both sides, derive the force which applies force to the hydraulic fluid, which I'm going to stop moving there. Okay, which brings the hydraulic fluid from this impeller to these meshing gears in here that the crank drives, turns the impeller in here, which drives these impellers, these meshing gears, which drives the hydraulic fluid, which turns the impeller in here, which drives this chain. I'm going to stop moving again. Okay, which drives this chain, which turns the rear wheel, and the same is true on the tricycle, and it turns the rear wheels. The amplification of force, as you can probably tell, is significant, since the sensor gear on these there we go. On sensor gear on these meshing gears is significantly smaller, the circumference significantly smaller than this drive gear from the crank, which applies force to the hydraulic fluid that turns this impeller, which has a significant radius, which drives which drives these meshing gears, which has a very small radius compared to the impeller radius of this impeller, which drives this impeller, which has a radius. Let me reduce this here, which has a radius, which drives this gear, which drives the rear wheel. The applied force at the rear wheel is calculated to be 1,800 pounds, while the applied force at the crank is 100 pounds. This should drive the bicycle at 250 miles an hour. However, the aerodynamics, since this bicycle does not have a body on it, is significantly difficult to calculate. So I have not calculated it, and I am simply estimating the top speed. Now, all these components of the drivetrain can be put down on the tricycle with the same result, and 1,800 pounds will be applied at the rear wheels, and the tricycle should go 250 miles an hour as well. So, with that in mind, I'm hoping that you will show some interest in my project and read my subject lines and visit Indiegogo.com. If you see this on YouTube,